Problem 13. A concave makeup mirror is designed. Concave is designed so that a person 25 centimeters in front of it. So this distance would be 25 centimeters. This little dot is a person. A person 25 centimeters in front of it sees an upright image magnified by a factor of 2. What is the radius of curvature of the mirror? So we're told that they see an image that's upright and magnified by a factor of 2. What does that mean? That means that our magnification is going to be a positive value, which indicates upright, and then it's going to be multiplied by a factor of 2. So what it's telling us is m is equal to positive 2. Now, it's asking us to find the radius of curvature of the mirror, which means we also need to find the focal length, right? So first we find the focal length, and then we solve for the radius. In order to do that, we use our formula. 1 over the distance of the virtual image plus 1 over the distance of the object is equal to 1 over the focal length, right? We know that the distance of the object, p, is 25 centimeters. We know what the magnification is. And so in order to find this, we can use our other formula here. Negative q over p. So this is negative distance of the virtual object over the distance of the actual object. So what this means is that we take positive 2 is equal to negative q over 25 centimeters. So that means that q is equal to negative 50 centimeters. So now that we know both q and p, we can plug into 1 over f is equal to 1 over negative 50 centimeters plus 1 over 25 centimeters. So f is going to be equal to 50 minus 25 over 1250. This is inverse. I'm just plugging into the formula, and I've dropped my units here just so I can quickly go through the calculation, which gives us 25 over 1250, which is actually equal to 1 over 50. This is centimeters, right? Because this would be centimeters because we square the units, right? We're going to end up, what I'm saying is 1 over f, as I've said before, is equal to q plus p over q times p. So this gives you centimeters squared, this gives you centimeters, right? But we're not really worried about that right now. So what this tells us, this is inverse by the way, what this tells us is that we have 50 centimeters as our focal length. So all I did was plug into the formula, and you can do the same thing by carefully going through the calculation. This is q, this is p, and I just did a little bit of algebra to solve. Okay, and then we're asked to find the radius of curvature, right? This is equal, so our focal length is always equal to r over 2, radius of curvature over 2. We're asked to find the radius of curvature, so we just take this times f. So r is going to be equal to 100 centimeters or 1 meter. It's a pretty big mirror, actually. Well, I mean, if you extended it, that's what I'm saying. Because what the radius of curvature is just going to be like if you just have a little concave mirror and you extended this all the way into a circle, this radius of curvature would be 1 meter, right? It's pretty interesting. Next problem, number 19. We have spherical mirror is used to form an image 5 times as tall as the object, so that's magnification is 5 times. 5 times as tall as an object on a screen positioned 5 meters from the mirror. That means our virtual image is 5 meters away. We're asked to describe the type of mirror required. And then we're asked, where should the object be positioned relative to the mirror? So they're asking us to find the value p in our formula. We should note that this was just the magnitude given to us in the problem. So we might still need to find if this is a positive or negative value. So if we're starting with part A to describe the mirror, we're told that there's a mirror and that a distance away an object is formed on a screen, right? An image is formed on a screen. So this is the screen, this is the mirror. The point being, this image is a real image because it's on a screen. So this is a real image, and the only way to get a real image from a mirror is if it's concave. Okay, so we have a concave mirror. We know that much. We can continue and find some more properties and describe the mirror in more detail. But let's say that from a concave mirror, a real image is going to be inverted, right? So this virtual image is going to be, I'm sorry, not virtual, real. This real image, the image is going to be inverted. So what that means is that we have a magnification less than 0. Okay? And we were told that the magnitude of the magnification is 5. So that means that we have m is equal to -5. Then we're also told that the image distance from the mirror is 5 meters. So great. So now what we have is this is -q over p, recall. And so that's going to be -5 meters over p, the distance of the object from the mirror, right? The distance of the virtual, I'm sorry, I keep calling it virtual. What I'm saying is the image. The distance of the image from the mirror is 5 meters. The distance of the object is what we want to find. Okay, so -5 is equal to -5 meters over p in meters. Well, if we solve for that, that's going to give us 1 meter. So that's how far it is. Now that you know P and Q, you can solve for F, the focal length of the mirror. You can solve for the radius of curvature. You can solve for, well, actually, that's enough here to build your mirror. So you can solve for these things and then build your mirror. So when it asks you to describe the mirror, this is a great place to start, but you can also identify these values